Hi, I'm Paul Bovingdon, Simulation Product Manager at Pickering Interfaces. Welcome to this presentation on the advantages of modularity when testing a battery management system. First of all, what are the challenges around BMS test and why is it important? As you'll likely know, the battery management system, or BMS, controls almost all functions of the EV battery pack, including cell charge levels and cell balancing, as well as monitoring environmental factors such as cell temperature. Developing test strategies can be difficult due to the size and weight of a real-world battery stacks, as well as the sheer complexity of the system and the associated safety implications in the development process. All this can lead to the requirement becoming quite a daunting task. The main focus on BMS systems is currently within the automotive industry, with the obvious benefits of electric vehicles, though aerospace is growing in this area also. In such industries, it is obvious to see why it is so important to reliably test the BMS systems as close to real-world conditions as possible. Failure to do so could have serious or even fatal consequences. With this in mind, testing of the BMS is clearly important in the initial development stage, as well as in any in-service updates or upgrades, so must be factored into the development, verification, and validation stages. As mentioned before, it is impractical to do this on real-world battery stacks due to the size of the systems and the safety concerns associated with them, so you need a reliable way of simulating a real-world battery stack instead. This is where hardware-in-the-loop testing comes into play. Hardware-in-the-loop systems are used to simulate physical inputs as well as external connections. In this case, the battery stack and BMS. To the BMS under test, these simulated inputs appear as real-world signals would, meaning that you can test the behavior of the system under test in a much more controlled and repeatable environment. Within your BMS test system, you'll need to be able to simulate all the real-world stimulus that would be present in the real-world system, which is not an easy task without an automated test setup. However, with all that said on the previous slide, it is easy to see the long-term cost of not doing such testing, both financially and with reputation. The only real way to have the level of confidence required in your BMS system is to take all the stimulus being simulated and build the automated test around it, ensuring that you simulate every combination of conceivable scenarios, ensuring the BMS reacts as expected. As you can see from the diagram, this can include many signals and connections, including battery cells, fault simulation, communication, charging, loads, temperature, and isolation checks. Now we've spoken why testing BMSs is so important. But why use a modular platform for this purpose, namely PXI, and what are the advantages of taking such a route? Choosing a modular platform based on commercial off-the-shelf technologies and standards could help lower the cost of your BMS test system, as well as saving time as you have the system the way you want it. It can also help to increase the throughput, as the system can be fully integrated and automated in both hardware and software, leading to optimization of your test routines, even running multiple test routings in parallel. PXI, which stands for PCI extension for instrumentation, is an industry-standard open architecture which is maintained by the PXI System Alliance and supported by over 60 of the leading test and measurement vendors. Having so many vendors support the architecture means that a system designer can pick and choose building blocks from the multiple vendors depending upon their requirements, rather than being tied into a single vendor. It can help to reduce the time required to configure and develop or redesign your test system for new emerging products and requirements due to the flexible nature of a system based on PXI, both in hardware and software. As your BMS and system complexity grows, a modular system can grow with it, only adding into the system what you need when you need it. This means you do not need to overinvest in the first instance, and your initial investment does not go to waste when your test requirements outgrow it. This also means that you can get precisely what you need. Due to the number of vendors offering PXI, you can generally find a module that will provide the functionality that you require or will develop it for your needs. You are not limited to a pre-configured system that a single vendor can offer that either falls short of your full requirements or far exceeds with the associated cost implications. This all means that your test station can be flexible without being cumbersome. Here we have an example of a very simple BMS test system. We have the Pickering 41-752A module that has 6 channels of cell emulation with built-in current and voltage readback, a 40-297 programmable resistor for stack isolation testing, a 40-263 RTD simulator for cell temperature sensor emulation, a 40-190B fault insertion module to enable fault conditions to be applied, including open and shorts of the cell, as well as managing the connections between the test system and the unit under test. We also have an SMU in the system to provide external power for simulating cell charging using the current sinks on the 41-752A module, as well as any additional system measurements that are required. All of this is contained within a single 42-924 8-slot PXIe hybrid chassis, providing a compact test solution within the PXI modular platform. Now, let's consider we want to scale up this solution as we move beyond the simple BMS system shown in the previous slide. For example, simulating a full battery stack of over 400 volts. As mentioned previously, you can actually reuse the modules and chassis that you had in the example in the previous slide. Simply purchase the additional modules required, both for the addition of cells and for the additional functionality. In this example, we have added an additional chassis, in this case a 42-925 18-slot PXIe full hybrid chassis, where we can add an additional 15 41-752A modules to make a 96-cell stack. It is easy to see that this can be further expanded to add further cells to this stack just by adding additional modules and chassis as needed. We can also still make use of the 42-924 8-slot PXIe full hybrid chassis for the other modules in the system, as well as the addition of a CAN communication module for testing the BMS communications. Due to the higher voltages now present in the system, we have also added a high voltage module in the form of the 40-330 750 volt uncommitted relay module. Having an open modular platform does not just apply to the hardware you select. It is also true for the software side of things too. An open platform means that you are free to choose your own operating environment, as well as your chosen programming environment and language. Due to these choices, vendors generally also provide a wide choice of APIs to fit your desired setup, along with application examples leading to quick software application generation. Being modular, it also provides an easy option for manually operating the building blocks of the system for development purposes and system debug through the use of graphical soft-front panels. Here we have an example of the use of soft-front panels that can provide a simple means of operation for the individual modules. These are actually the individual panels associated with the small system in a previous slide. Also shown is how the APIs can be used to create an integrated graphical panel for the test system as a whole, in this case showing the simulated charge levels of the cells, simulated cell temperature, as well as if the cells are charging, discharging, or idle. Using a modular platform can also have support advantages. As you are not tied to a single vendor, if there is an issue with a particular module or supplier, you have the option to look elsewhere without changing your whole architecture. There is also a large global network of integrators that are familiar with the PXI platform, meaning there is a familiarity within the test and measurement industry. With thousands of systems installed worldwide, you can have confidence in the long-term support of the platform. Being modular with a global network of users, maintenance of the system is also eased, reducing system downtime. This is because you are free to choose your preferred integrator for your given system, as well as each element of the system having the ability to be tested as a standalone module and easily swapped out and repaired. With the building blocks being much smaller, it is also easier to hold and ship spare parts for the system. So, in summary, there are many advantages in BMS test. Many challenges in BMS test. It is imperative to test the BMS under real-world conditions. Accurately simulating all conditions is not easy, but could be costly if skipped. Using an industry-standard modular platform like PXI has many advantages. It can increase test throughput, lower cost, lower system redesign time, provide flexibility in both hardware and software, as well as easing support. We mentioned the multi-vendor PXI platform, of which Pickering Interfaces is a leading supplier. Pickering Interfaces has been designing and supplying platform-independent switching and simulation solutions since 1988. We have sales and support centers in the UK, US, France, Germany, Sweden, Czech Republic, and China, as well as a large network of agents. We are active within PXI and LXI, being sponsor members of the PXI System Alliance and LXI Consortium. We have a deep product portfolio, which includes over 1,600 PXI modules and 290 LXI products. We have a strong customer focus, providing COTS and custom designs, interconnectivity design and manufacturing, and field diagnostic test tools. We provide long-term support, still supporting products that were designed in the 1980s and rarely obsolete products. Pickering has an established and ever-growing offering in the area of BMS test. This includes the modular PXI and PXIe chassis, as well as modules including battery cell emulation, fault insertion for simulating shorts and opens, temperature emulation through thermocouple, RTD, and thermistor simulators, as well as programmable resistors for isolation testing and low power loads. Pickering also offers an extensive range of connectivity solutions, including connectors, cables, and breakouts, as well as offering a custom cable service supported by our own online design tool. If you'd like to find out more about Pickering's offering in this area, please go to pickeringtest.com/BMS or contact your local sales office. Thank you for your time.